Hi, we're going to be talking about quadratic equations still, but in particular, we're going to focus on the answers and the relationship the answers have with the values of a, b, and c in the original quadratic equation. So I have 7 examples. All the examples have the a, b's, and c's values listed, have the answers listed, and then they have the values for what the two answers add up to and what the two answers multiply to. There is a relationship between what the answers add up to and the values of a, b, and c. And you could compare them all, and I will show you. Let me highlight. So for the first example, the two answers add up to 8. And if you notice, that's negative 8. Now, it's a little bit more involved with that, but I'll start with that for a second. The value of the second row, they add up to negative 2, and notice that that's positive 2. The next one, the answers add up to negative 6, and the b value is 6. And then the next one, the answers add up to 5 halves, and you're like, well, that's not 5 halves, that's negative 5. So it's a little bit more complicated than just saying that there's a relationship with just the b value. In fact, the sum of the answers has a relationship where they're the opposite of the b number, and then it's divided by the a number. And these other a's were all 1. That's why you saw the values not changing, because anything divided by 1 is itself. So there's a relationship where, if you notice the sum, it's negative 5/3. And then the b value is positive 5, and then the a value is 3. So there's your relationship, opposite of b divided by a. Okay, so even when you get these answers, the answers to irrationals and imaginaries are actually conjugates. So they will always add up to a nice value and multiply to a nice value. So there's your negative 4, and there's your positive 4, and your a is 1. That means it didn't change 4. And lastly, this right here is negative 6, and there's your positive 6 because a is 1. So the relationship for question 1 between the value of the roots, what they add up to, and the a and b values is this. The sum of the roots equals the opposite of the b number divided by the a number. All right, now taking a look at all the equations again, and this time looking at the product of the roots. So in the first problem, they multiplied to 12. And if you look at the variables a, b, c, you'll notice there's a 12 here. And again, it's not that simple, but kinda. This value multiplies to negative 15, and look at what c is. This value is 5, and then look at what c is. This is negative 6. Oh, but that's negative 12. So it can't just be that these two match the numbers. The same relationship with the sum is involved here. This product value is actually dependent upon the c value and also the a value. So let me erase these. So it's actually a relationship between the a and c values. So when you finally get to this one, negative 12 divided by 2 is your negative 6. 2 divided by 3, there's your 2/3. Negative 2 for the product is your c over a. And finally, your 10 here, there's your 10 over 1. So those are the two relationships we're going to deal with. That the sum is equal to the negative b over the a values, and then the product. Okay, I ran out of room here, but I'll write it here. The product of the roots equals the c value divided by the a value in the equations. So when you look at an equation, you now know before you even begin what the answers should add up to and what the answers should multiply to, and that will be a great way to also check your work. Okay, so here are your vocab words. When you hear the phrase sum of the roots, that implies what the two answers of a quadratic equation add up to. And I'm sorry, it does not have to be just a quadratic equation. Sum of the roots just means the sum of all the answers. But we're dealing with quadratics today, so that's why I chose that in our vocab. Product of the roots for the quadratic equations are what the two answers of a quadratic equation multiply to. All right, and I did provide those formulas, so you need to know these formulas. Now, if you ever forget the formulas, you can always find the sum by resolving the quadratic, getting the actual answers and adding them. That will just take much longer than it's needed. And the product of the roots is equal to the C value over the A value. So going on to question 1, it says, what is the sum of the roots of x squared plus 5x minus 8 equals 0? Well, again, if you really forget the formulas, you could solve this all out, take your answers and add them. That's way more work than you have to, because we have our formula, and here are our values. I know without adding them that the sum of the roots is going to equal the opposite of the B value over the A value. So the B is 5, so that'll be negative 5, and the A is 1. So without solving them, I know whatever the answers are, they're going to add up to negative 5. Next question, what is the product of the roots? Again, product of the roots is what do the answers multiply to? I could just solve them, take my answers and multiply them. Or I can remember that the product of the two answers are going to be whatever the value of C over A is. And C is negative 8, and A is 1. So whatever the answers are, they're definitely going to add up to negative 5 and multiply to make a negative 8. All right, we'll try this one more time. These are actually typical questions on a Regents. So what is the sum of the roots of the equation 2x squared minus 7x plus 6? Well, our A is 2, our B is negative 7, our C is 6. So the sum is equal to negative B over A. Again, the B is negative 7, so this is going to change to positive 7, and the A is 2. Whoops. You can leave it as 7 over 2, or you can write it as 3.5, whichever you prefer. The product is equal of the roots is equal to the C value over the A value. So the C is 6, the A is 2, and that's 3. That means whatever the answers are, they're going to multiply to make a 3, and the two answers will add up to a 7/2. All right, those are your typical questions, and here's an extension of using the product and sum formulas. Problem 3 says, write a quadratic equation such that the sum of the roots is negative 2 and the product of its roots is negative 24. So basically that is telling me that the two answers are going to add up to negative 2 and the two answers are going to multiply to negative 24. Now we can do this in one of two ways. Method 1. If I know that the sum is negative 2, I know that it has something to do with the negative B over A formula. So we're going to put a negative 2 in for the sum. Oh, let me start with the formula first. Excuse me. So here's my sum formula. Here's my product formula. All right, so the sum is equal to negative 2. But I need to figure out basically what my A, B, and C letters are. If I know what my A, B, and C letters are, then I can figure out what my equation is. Now they tell you that the sum is negative 2, and then they tell you that the product is negative 24. Well, that's all I have. Now they told you to write any equation. They didn't actually say a specific one. So what we're going to do is we notice that there are both formulas have an A in them. So we are just going to pick any equation that we want. So we're going to have to choose a number we want for A. And to pick a number for A, the easiest one would be to use the number 1. Although we don't have to. If we chose to use a 2, it would still work. It would give you a new equation that would still be a correct answer. So we're going to replace now this with a 1 and that with a 1. So how would you solve that? Well, now you have two proportions. You can put that over 1 and cross multiply. Keep in mind A is 1. We just found out that B is 2. And then if we do the same thing to the other one, we get C is negative 24. So putting that all together, we get 1 is the A value, so that's going to be 1x squared. B is 2, so that's going to be plus 2x. And C is negative 24. And don't forget, it told you to write an equation. An equation needs to have an equal sign. So you get answers, the roots are where this is equal to 0. Now, once you do a lot of these, you're going to realize that something else special happens. Because we're letting A be the number 1, if you go back to the Use What You Know page, every time A was 1, it actually just dealt with the B and C numbers. So some of you guys, and I'll give you a little helpful hint, will realize that if the sum of the roots is negative 2, that means the B is going to be 2. And if the product of the roots is negative 24, then you know that the C value is actually going to be a match. And so you get really good at these if you just notice that these basically make opposites. And these are the same. And that works if A is 1. And you can do an equation each and every time like that. The other way you could do this problem is that you could try to figure out what the actual answers are. This does not always work, but if there's a way to figure out what two numbers add up, so I need two numbers to add up to make negative 2, but multiply to make negative 24. Well, let's see. Negative 24, I have these choices. And then I'm going to stop because I just found out the pair that adds up to make negative 2. These two add up to make negative 2. So once I figure this out, and you can't always do it. This only works if the answers are going to be real, rational answers. But if I can figure out that those are the answers, I now have the answers, which means I can figure out the factors from my answers. The factors would be to subtract the 4 back over and add the 6 back over. And if you double distribute this, you will get back out this, which is the answer that we got above. So most people like the first method because it's pretty easy, but if you ever forget, there is a way out. Problem number 2, we're going to write a quadratic equation again. But this time, they give you one of the answers is 4 plus I. So if I go back to the Use What You Know, I don't know if you realize, but the answers to the irrationals and the answers to the imaginary answers, you get actually a pair of conjugates as the answers. So if they give you an imaginary or an irrational and only one of them, you know that means that the other one is the conjugate. Now the reason why that's important is now that I have my two answers, I can now figure out what the sum of those are because I can take my answers and add them. And 4 plus I and 4 minus I, well, 4 plus 4 is 8, and the negative I and I cancel. The product is going to be whatever these multiply to make. All right, and if you put that into your calculator, you will get 17. And now if I want to write an equation, if I let A be 1, I know that the B value then is going to be the opposite of my sum, and I know the C value is going to actually equal my product value. And then here's my equation, 1x squared minus 8x plus 17 equals 0. And last question, if 1 root of x squared minus 6x plus k is 0, or equals 0 is 4, find the other root. That means find the other answer and the value of k. There are many ways to answer this problem, so I'm just going to pick one way, but if you can think of another way out, that's fine. So what do we want to do first? Well, the one thing we may want to do first is to find the other root. That actually would be a faster way to do it. And how would we find the other root? Well, the other root, I know for a fact that I have the a is 1 and the b is -6. A and b go with the sum formula. So I know that the sum is equal to -b over a, which would be +6 over 1, which is 6. Now, you're asking probably, why does this help me? Well, if one of the roots is 4, that is telling you that x equals 4. Now, my goal is to find the other root. So my question is, what's the other root? Well, if I know that the sum is equal to 6, then I know I have to figure out what do you add to 4 to make a 6. And so it's easy. It's 2. So my other root is 2. If you don't like that method, you could take the 4, replace it with all the x's to find the k, and that will answer the b part. Or you could, and then you have to refactor to find the other root. So to do the b part, there are now 2 ways to do the b part. You can do what I just showed you and take the 4, plug it in for x like this. And you get that's one way to do it. The other way to do the problem is to go, okay, I know that the c value is related to the product, so you could just figure out what the product is. The product of the 2 answers is 4 times 2, which is 8. And so now I know that the product is equal to c over a. The c is k and the a is 1. And then I can just cross multiply and do k is 8. So it's all in how you want to do the problem, what information you have. If you have the root, you have the x value. And if you have the sum and the product, then you know that that refers to some relationship with the b and the a and the c values.